There are over 4,000 minerals that are known in nature, but fortunately only a couple dozen of those are real important, real common, and those are typically the ones that are found in rocks. We call those the rock-forming minerals. Now, with a little bit of study, it's fairly easy to learn how to identify some of the most common minerals. My best advice for someone who is interested in minerals and collecting them is to get a good book on mineral identification. This is just one example. It's called Minerals of the World by Johnson, and it has full-color photographs of minerals. Most importantly, in the back, it has a table of mineral properties. So if you have an unknown mineral and you want to identify it, you look at some properties to see what it might be, go through the table until you see something similar, and chances are, unless you've got some oddball mineral that's similar to a more common one, you've identified what you have. Now, as we look at minerals, there's basically 7 tests that we do. We don't have time to go into them in great detail, but let me mention them quickly here. One of the things we look at is color. Some minerals have distinctive colors that almost as soon as you see it, you can tell what you have. Others are more subtle. For example, fluorite here occurs in a wide range of colors. This one happens to be purple. The second test is called streak colors. In a streak, you take a piece of unglazed porcelain and you rub the mineral against that and you get a little powder. And the interesting thing with fluorite, once you've gotten that powder, no matter what color the specimen is, your powder is going to be white, which reduces some of the variation that can occur. A third thing we look at for a mineral is its luster. Some minerals are glassy in appearance, others are metallic, some of them are dull and earthy, and we use just common terms to describe what they look like. Another thing we look at is hardness. For example, we can take this specimen of quartz, which is a very hard mineral, and we can scratch many other minerals with that. And when we do those scratch tests, we can pin down a numerical value of what the hardness is going to be. Another thing we look at is density. If you have a mineral that has a high metal content, for example, galena, a lead ore, it's going to be very, very hefty, very dense compared to another mineral the same size. Another thing we look at is the crystal habit. Do we see crystals? And the shape of a crystal and the angles at which the crystal faces meet, that's another thing that's going to be very distinctive. And then finally, we look at how a mineral breaks, or more properly, how it has broken, because we usually don't go around smashing our specimens. But if we look at this piece of calcite here, which accidentally was broken a year or so ago, you'll notice that it broke along very flat surfaces. And that indicates a weakness in the crystal structure, where the atoms basically just separated. Other materials will break irregularly, and if that happens, for example, in quartz, you can see where this crystal broke off. We said it has fracture rather than cleavage, which is the characteristic of breaking along a flat plane. So once you've looked at some minerals and identified how to distinguish these properties, it's not too hard, with the aid of a good field guide, to tell what type of mineral you might have.